In this video, I am going to discuss about the previously asked questions from CSIR and GATE examination of this Shapiro reaction. So, Shapiro reaction is a method to prepare alkenes from the carbonyl compounds. So when we take carbonyl compounds and react it with tosyl hydrazine, we get tosyl hydrazones. And these tosyl hydrazones, on reaction with two equivalents of butyl lithium, we will get the alkenes. So what are the important points are the key points to be remembered in this reaction. So this reaction requires two equivalents of base or minimum two equivalents of strong base like butyl lithium is needed. And the reaction is kinetically controlled and we get less substituted alkene as the product. And most importantly, the electrophilic carbon becomes the nucleophilic in the product and the electrophile will attack at the sp2 carbon. Let us consider the example of the carbonyl compound. This is cyclohexanone. So cyclohexanone on reaction with tosyl hydrazine, we get tosyl hydrazone, that is double bond N, NH and the tosyl. So these lone pair of electrons will attack on the electrophilic center of the carbon and water is removed and we get a tosyl hydrazone. And on this tosyl hydrazone, two equivalents of butyl lithium, N-butyl lithium will attack and we get an alkene. So let us quickly look at the mechanism of this reaction. So on the tosyl hydrazone, double bond N, NH and TS. So the first mole of butyl lithium will abstract the most acidic hydrogen, that is the NH. Then we get double bond N, N minus and TS. So on this compound, there are two alpha hydrogens. So this is one alpha hydrogen and the other is the alpha hydrogen. So abstraction of either of the hydrogen will give us the same product. So the second mole of butyl lithium will abstract the alpha hydrogen and then we get a carbon ion intermediate, that is minus and double bond N minus and TS. So this bond will move over here and this will shift over here and the tosyl group will leave and we get the intermediate, the diazo compound N double bond N minus and here we have a double bond. So this is the diazo compound and on this diazo compound the nitrogen will be eliminated. This will shift over here and this bond will shift over here and we get a negative charge over here and a double bond. So on this, if we do the workup, we get the H plus as the electrophile and this is the product that we are going to get. So the point here to be remembered is the alpha hydrogen is abstracted from the less substituted side. So in this case there are two alpha hydrogens but both are identical. So let us take the example where the cyclohexanone is substituted. So here we have a methyl group on the cyclohexanone. So if you react it with the tosyl hydrazine, then we are going to get the tosyl hydrazone. NH and TS. So here there are two possibilities of the alpha hydrogen. There is one hydrogen over here, and the other is here. So the butyl lithium, since it is a bulky base, it will always try to abstract this hydrogen. So because this is the more substituted one, so the product that we are going to get is there are two possibilities. One is this one, and the other is this one. So since butyl lithium will abstract this hydrogen, since it is less substituted, so the product that we are going to get is this, and this is not the product that we are going to get. So let us look into the other question, where we have the tosyl hydrazone, and this is also an unsymmetrical one. There are two alpha hydrogens over here. This is one alpha hydrogen and this is one alpha hydrogen. Oh, this is the more substituted one. This is a tertiary and this is the secondary. So the butyl lithium will abstract this hydrogen, and the product that initially we get CH3, and since this hydrogen is abstracted, we get this as the alkene, and this is the electrophilic center, and that will become the nucleophilic center. And on this nucleophilic center, DMF, that is NN dimethyl formamide, will attack. So that is the carbon ion will attack on the electrophilic center, and this will go off, and the product that we are going to get is CHO. So from the DMF we are going to get the formyl group. So here this is the product that we are going to get. So similarly we have the example over here where there are two alpha hydrogens. So this is one alpha hydrogen and this is the second one. So the second mole of butyl lithium can abstract either of the one because they get the identical product. So the attack on this butyl lithium, we get so butyl lithium we get this alkene, and to remember, this electrophilic center in the starting material will be the nucleophilic center. So on this the benzaldehyde, that is PHC double bond OH, this will go and attack over here, and this, and the product that we are going to get is a secondary alcohol. So P is this one, and Q is the secondary alcohol. And let us now look into this example. So what is the major product formed in the reaction? So now we know that there's only one alpha hydrogen. This is the alpha hydrogen. So the product on reaction with that butyl lithium, we are going to get, since there is only one possibility of alpha hydrogen, so this will be the alkene that will be formed. And this was the electrophilic center in the starting material, and now it will be the nucleophilic center, and the product that we are going to get is this one, A. So this is the one more question where we have the tosyl hydrazone. And this tosyl hydrazone, there are two possibilities of the alpha hydrogen. This is one and this is the second one. Since this is the more substituted one, so the butyl lithium will abstract this hydrogen and we get a double bond over here, and this double bond will attack on this double bond where and this will attack on the DMF, and we get this as the product. So from the DMF we are going to get the formyl group.